All right, so we're taking a look at some solutions to the extra practice trig problems. And so I'm working off of this sheet here. Let's see if I can get it to zoom or focus. Can you focus? Yeah, that's pretty good. Okay, so I'm going to be running through this. This is on our class website. So let's give it a try. All right, so number one, we want to try to evaluate. 1a is to evaluate the sine of 3 pi over 4. So over the side here, we'll take a look at the unit circle. And so let's see, that'll be pi over 4. That's 2 pi over 4, which is pi over 2. And then 3 pi over 4 is over here. And so what are the coordinates at this point? Well, over here, it's 1 over the square root of 2, 1 over the square root of 2. That's from the 45, 45, 90 triangle. And so the way to get over here then is just to take the x and make it negative. So that's minus 1 over the square root of 2, 1 over the square root of 2. And now the sine is the y value. So actually, it's just going to be 1 over the square root of 2, right? And you can leave your answer in non-rationalized form. That's fine. B, cosine minus 5 pi over 4. Okay, so where is minus 5 pi over 4? Well, this is minus 1 pi over 4, minus 2 pi over 4, minus 3 pi over 4, minus 4 pi over 4, minus 5 pi over, oh, so it's the same point. So that's going to be minus 5 pi over 4. And so now we want the cosine, which is going to be the x-coordinate on our unit circle. And so that's going to be minus 1 over the square root of 2. Good. C, tangent of 2 pi over 3. Maybe I'll draw a new circle. Okay, so that's about pi over 3 there. And so 2 pi over 3 is over here. Now, do we remember what the coordinates are there? Remember, this is coming from a 30, 60, 90 triangle. I'm trying to draw that so that's pi over 6 and pi over 3. And so this would be 1, 2 square root of 3, right? And so let's see, tangent of 2 pi over 3 is over here. So what are these coordinates? Well, the x-coordinate is shorter than the y, so that's going to be 1 over the square root, or 1/2 square root of 3 over 2. Okay, and so if I put it over here, then the x-coordinate becomes minus 1/2, and then square root of 3 over 2. Good, and then the tangent is going to be opposite opposite over adjacent, so that's going to be minus the square root of 3, right? Good, or you could think of it as sine over cosine. Part D, secant of 7 pi over 6. Well, first off, where is 7 pi over 6? Let's see, so 8 pi over 6, or 6, well, let's do 6 pi over 6. So 6 pi over 6 is just pi, right? So it's pi 6 past pi. So that's going to be pi over 6 past that. And so if we think about that, you could think of this as being a reflected point from here, and that's a reflected point from here, right? And that point is the square root of 3 over 2 1/2. I'm just slipping those coordinates. And so this would be negative on the x-coordinate, and then this would be negative on both. So this coordinate right here is minus the square root of 3 over 2 minus 1/2. And so the secant is 1 over cosine, right? And so the cosine is the x-coordinate. So I'm going to have minus 2 over square root of 3. Good. All right. What's next? E, cosecant of 29 pi over 6. Now 29 pi over 6 is just about 30 pi over 6, which is 5 pi. And 5 pi is over here. So it's pi 6 less than that. And so that's going to be 29 pi over 6 right there. And so we've already got our coordinates set up for that. And so cosecant is 1 over the sine. 29 pi over 6. And so the sign is our y-coordinate, and so our y-coordinate is positive here, right? So that's going to be the positive 1/2. Good. Oops, it's 1 over 1/2. Sorry about that. And so that's 2. Good. And then finally we have just tangent of pi over 4. Let's see, over here we had pi over 4, right? So tangent is opposite over adjacent, or 1 over the square root of 2 divided by 1 over the square root of 2, and that's equal to 1. Very good. So that's number 1. So that was getting practice with the unit circle. Number 2 is what is the amplitude, period, and frequency for 1 plus 2 cosine of 3x. So really we're just working with 2 cosine of 3x because that's just shifting the curve up. So that doesn't affect either of these, or any of these, I guess I should say. And so when you're working with a sine of omega x or b cosine of omega x, I guess I could make that a too. Then the a is the amplitude, and then the period comes off of the omega. The period is actually 2 pi over omega. And then the frequency is 1 over the period. Okay, so in our case, we can just read those off. Amplitude is 2, frequency, or sorry, we usually do period first. 2 pi over 3. And so then the frequency is the reciprocal of that, 3 over 2 pi. Very good. Let's see, do I have time for the next one? I think so. Before I'm trying to keep these fairly short here, so we'll cut at about 10 minutes. What is the period of the tangent of pi over x? And then what is the period of cosine of x over pi? Well, I guess one question would be, does the tangent of pi over x have a period? Right, because what would it look like? This is going to be the sine of pi over x divided by cosine of pi over x, right? And so, yeah, that's not really the period. That's kind of a trick question. I shouldn't have put that on there because this really is not periodic, right? Cosine of pi x kind of piles up the zeros along the well, the zeros. So what happens here is that the sine of pi over x becomes 0 faster and faster as you get to x equals 0, and so this is not a periodic function, right? The cosine is going to be 0 along there too, so you're going to have these vertical asymptotes piling up as well, and so that's not going to be periodic. Okay, on the other hand, this x over pi is periodic because you can think of this as this form, right? With our, where's the form? Here it is. That form with w equal to 1 over pi. And so in this case, we have the period is 2 pi divided by the w. And so if that's 1 over pi, right, the pi flips over. And so that's going to be 2 pi squared. Good. Okay. So that wasn't a very good question. But in the next video, we'll start with number 3, or number 4. Solve for x. So just as a reminder where we're at, we're going to start there. Solve for x. See you in the next one.